Hello and welcome back. We've got another question here today. Let's read it. To find the sum in an odd-sided array, you might think of those as magic squares. For n equals 3, 5, 7, and so on, you can use these formulas. Sum equals n cubed plus n all over 2, or we've got sum equals a half times n in brackets n squared plus 1. We want to show that the sum is 15 using both formulas, and that's for n equals 3. So if we use our left formula first, let's use a nice color for that. Let's use this blue here for this formula here. So if we say the sum is equal to 3 cubed plus 3 all over 2, that's going to equal 27 plus 3 all over 2, and that's just going to be 30 over 2, which is 15. Okay, the left formula is looking good. And let's use this purple for this right sum. So if we've got the sum equal to a half times 3, open bracket 3 squared plus 1, this will equal, well, let's make this 3 over 2. Inside the bracket we've got 9 plus 1, and 9 plus 1, that's 10. So 3 on 2 times 10, that's going to give us 30 over 2, which is 15. That's pretty handy. Both of our formulas are 15. Good. Now, what is the sum in a 5 by 5 square? Well, that just means we want to use n equals 5. So let's just do that in here. N equals 5. So the sum will equal 5 cubed plus 5 all over 2. 5 cubed, that's just going to be 125 plus 5 all over 2, which is 130 over 2, which is just 65. Now for question C, what is the side of a square if its magic sum is 175? Okay, so this one's a little bit different. This time it tells us what the sum is. So the sum is equal to 175, and n, we don't know. N is what we have to find. So I really like that left formula, the light blue one, so I might continue to use that. It doesn't matter which one you use, both will give the same result. So let's say 175 equals, oops, not m, n cubed plus n all over 2. So we want to get the n by itself. So our next line of work, let's get rid of that divide by 2, the all over 2. So what is 175 times 2? That will just give us 350 equals n cubed plus n. Now, you can't get a single value of n on its own here. We've got n cubed plus n. We can't factorize it. We can't reduce that in any way. So we might have to do a bit of trial and error. But we already know n equals 5 was 65, not 175. And we also know all of these have to be odd numbers. So if we try n equals 7 or 9 or 11, that kind of narrows everything down for us. So to begin with, well, let's put a dot dot dot. Who knows how big it could be? Let's try n equals 7 to see if that works here. So 350 equals 7 cubed plus 7. What is 7 cubed? 7 to the power of 3. That's just going to be 343 plus 7. This is looking pretty good. 350. We've got it. But we want the side of a square if its magic sum is 175. We can double check that. If we just sub in n equals 7, it should give us 175. You can check that yourself if you'd like, but I'll move on to the next question. Question D, show how the two formulas are the same. Okay. The blue and the purple formula, they look similar, but not quite the same. The one on the left, the blue one, we've got an n cubed. The purple one, we've got an n squared. So let's see what we can do with that. So I'll go back to my colors and I'll write n cubed plus n over 2. Now on top, in my numerator, I could factorize. I could take out a factor of n. And if I do that, I'll have n squared plus 1 left over, all over 2. This is looking pretty close to my purple formula, but that half, that's just hanging out the front there, whereas here we're dividing by 2. Well, we can also take that divide by 2, or all over 2, out the front, and we can say 1/2. If you want, you can think of it as factorizing the bottom term, and open bracket n squared plus 1, close bracket, all over 1. That 2 here, we've taken it out the front, and we factorize it. What would be left over? Just a 1. And of course, anything divided by 1 is just itself. So we don't really need to write it as a fraction at all. And that is equal to, obviously, our purple side. And clearly, I've got just the right amount of space there. So we've shown that the two formula are the same. All right, that's all that we've got time for today. Thanks for joining me, and I'll see you next time.